I was just checking the diodes and everything I put together before I put anything back, and I snapped the end off of this stupid diode. I have to go figure out what it is now and get a replacement for it. Well, that was a rather overdramatic entrance. I'm really sorry I don't really have anything to follow up on that, as the actual quest for diodes wasn't as problematic as I first thought. As I stated before, EDI, Electronic Devices Inc., the original manufacturer, was still in business, and they had a website, and according to their website, the DL800 was still a current product, though its name has changed. But I couldn't find any way to buy one from their site. So I filled in the dreaded leave us a message form and hit send. Well, much to my surprise, I got a response right away, and they basically stated that they no longer sell directly to customers. They now sell only to OEMs or industrial clients. And all these sales go through regional distributors. Well, at least I got the regional distributor for my part of North America, and the engineer I chatted with is nice enough to send me the latest data sheet for the DL800. Now, the distributor was only too happy to sell me some DL800s, but I had to buy a minimum 50. Now, as chance would have it, I was chatting with one of my buddies from the radio club, and he said I should try a company called Voltage Multipliers Inc., as they had provided him with many small lots of high voltage diodes for his work with lasers. So off to their site I went, and after a little puttering around, I found some diodes that might work. Well, I must say the folks over at VMI were very, very helpful. Seems it's been a company policy since the beginning to always provide engineers with the quantity of diodes they need, no matter how small or large. I also had one of their engineers call me, and we went over exactly the requirement I need, and he suggested the diode that best fits. Now comes the tricky part. The fact that I needed 5 is no problem. They would readily sell me that small quantity. The real problem comes from the fact that any diode that's rated for over 5,000 volts is subject to export restrictions by the United States Treasury Department. So I had to fill out a whole pile of forms, answer a whole whack of questions, and I had to use a bonded carrier to have them delivered. So the diodes have finally arrived. It didn't take too long, just 1 or 2 days, but look at the size of the box for 5 diodes. God knows what's inside here. Let's open her up and see here. Maybe I got a surprise and I don't know it. But that is a lot of packing for 5 diodes. Okay. Box in a box in a box. Curiouser and curiouser. Let's see. As Alice says. Oh! Ooh, letter. Oh, all sorts of stuff. I think they sent me more than 5. Cool. More like 500. Okay. Well, maybe not. 5? Nope, then only 5. Just a big box of them. Yeah, there you go. It's a lot of packaging for 5 diodes. There they are. Little bitty penny ones. Yeah, well, cool. Well, gotta go put them in now.
20 minutes later.
The problem is, oops, get this over without breaking more wires, is my other diode to replace is way at the bottom down in here. You can't even see it. Maybe if I zoom in. Oh, this thing's hard to work with. You can see it there. It's going to be a bugger to get that out of there without burning something else out. Okay. Yeah, right down in there. Yeah, there it is. Right there. I should use this end. D800. Yuck. Well, at least the other one's fit. The other one goes there. That's the diode end of it. But I'll double check that. Like the other one, it's really, really soft metal on there. You can see why they say they should heat sink them before you put them in.
Later that same evening.
Well, nothing special in replacing the diodes. They were a little tricky to get at least the one inside the transformer box. As you can see in this photo, I used a little clip just to act as a heat sink on the lead. And looks like I'm all done now anyway. Alright, I had a look at them all and they look perfectly fine, so we'll just clip these off. 1, 2, 3, and 4. Good. Good, and good. This thing. It's hard to play with because the resistors are on this board. The test points are on the other side, way over there. And this board has to be in place up there, all nicely put in. So, yuck-a-doo. I did also notice that these resistors here are out of spec, but I looked at the schematic and they don't look too bad. So let me get this back in place and get cleaned up here. And put these diodes. The other diode just broke off like the other one did, so they don't last long, these DL800s. Anyway, I will clean up and then put everything back and get ready to do a test.
A little longer than a few minutes later.
Alright, I'll reset. I'm going to throw the power, turn the isolation transformer on. Hopefully no magic smoke or funny sounds. Funny sound. Let's see what the voltages are like. That's not right. Not good. Red and white should be 240, and I'm getting that funny sound again. Orange, 16.5, and it's bouncing around. 3.9, bouncing like a pancake. So something's wrong. And it's making that funny noise. Me thinking this is dead. I'm going to investigate that, but I'm not going to poke around.
1 hour later.
This is the test setup I used when I finally figured out what it was. So, as I say earlier, I isolated the different parts of the circuit, checked the transformer, checked that, and what I decided to do was test the oscillating circuit. So, the oscillating circuit, just disconnected it. That's the power input for the oscillating circuit. It's getting 5.2 volts now, going through that cap and coming up to this triple nickel here, and it should be running at 42 kilohertz or so. Before it was running at 142 kilohertz, and what was the problem was this cap. We'll zoom in there. This cap right here had a bad solder joint. I just resolder jointed, reflowed it, got it connected. It was this end because it's right near the end. It got bashed. It worked once before when I was putting this on, and that led me. Then when I took it off and tested it again, it didn't work. So that's actually working. And you can see now, if I go commando for a second, there we go. Now I'm getting 35 kilohertz, which is about right. And that funny noise I was getting was that it was giving me 100 kilohertz. It was just buzzing too fast for the system to catch up to it, so it wasn't generating any power. It was just humming. So we'll see what happens now when I put it back together. Alright, a quick test. Hopefully no buzzing sound this time. I'm gonna throw the switch. Yay, no buzzing.
I think I'll put it back together and see what I get. So as I was putting it back together again, this diode here kept on popping out all the time. Fortunately, it's just a 1N404, so I'll just swap that for a longer one. Problem is it was clipped very close, and so it didn't come out very well. I'll just swap it for another one quickly. Hopefully that's the end of me problems. But you never know. So let's see if that fix did the trick. Before I put it back in the box, I want to make sure I got the correct 120 something volts going across there. Okay. And I'll throw the switch. Hey, 122.8. Perfect. 123. It's supposed to be 123.5. Yes, that's perfect. Good. I'm going to put it back together in its box, then retest it, then take a calibration. Alright, before I put it together for the hopefully last time, I gave the bottom a good relayering of heat sink white goop. Got my screws all there. Okay. Take out that screw and start putting it back together.
12 seconds later.
So there's no end to fun on this. I just had gotten up in this box and was testing and noticed that there was a wire off again. I'm going to go through and check all the wires one more time to make sure it's alright, then give it another test.
15 minutes later.
Alright. Now hopefully my last voltage check. So red and white, which is this one. 245.1, that's a little better. Point 1. Orange and white, which is this one. 129.1, that's much better than 139. Red should be 5 volts. 5.07, perfect. Orange should be 15 volts. 14.82, that's fine. 82. And finally my bluey should be minus 15 something. Minus 14.8. So my voltages are fine. Yay. What's the date today? 2002. Okay. Let's see if I can get a trace out of it now. So I got to flip her over on its side. Give me a minute to set that up. Let's go through. Power off. Position, channel A, centered. Centered. Position horizontal. Good enough. Mode. A. Mode? Where's mode? Okay. A. Okay. Channel A. Volts. 1 volt. 1 volt. Can't see that there. Variable channel A and B. Vertical switch AC. Invert calc clockwise. That's on calc. Internal into external and normal. Normal. TV norm to norm. Auto to norm. Auto. So auto in. Yeah. Okay. Level. Centered. There's level. That level. Triggering level. Time 2 seconds. 2 milliseconds. Chop milliseconds. Okay. Alright. Count clockwise. Alright, here we go. I'm not seeing anything yet. Nada. It says give 3 minutes. Okay. Doesn't look good. Probably way out of calc because I was playing with it. Ah! We have trace. There we go. Hey! How about that? Cool. Alright, I have to... That curving upwards is because the CRT has moved a bit. I'll have to change that around. But we have a trace. How about that? That is happy. Me happy now. Okay. Let's see how badly B is working. Volts. 1 on calc. Position... there somewhere. Let's put it on B and see what we get. B. There's B. Not too bad. It's off a lot. Alright, so it needs a little calc. First thing is a mechanical calc. Straighten out that line a bit. Okay, so hoorah! So this is a mechanical calibration. Actually, it's easy to do with the camera. All I'm doing is I'm twisting the back of the CRT to get it straight, and I can watch the camera doing it. Let's see how that's going. Just a little. That looks about right. And then you just tighten the screws up. And you double check to make sure it's still okay. Good. So, zoom back out here. Flip her around. Good old analog scopes. You see there's 3 screws here. You unscrew them and you just twist this way. And then when you're done, you tighten them all up, down, and good. There. Okay. I think it's time for calibration. What do you think? I'm going to go read the instructions.
The calibration was straightforward and didn't require any special equipment or function generators, and it really didn't take that long. I was going to include the full calibration in this video, but unfortunately... That's right, when I unplugged it from the isolation transformer and plugged it into mains directly, I blew not 1, but 3 fuses.